Recently, I've been playing with the Chat GPT AI program, and I've asked it to convert a short C program that I had written previously into Rust. And I wanted to see how well it could do it, sort of unaided. Now, the C program is related to something I did when I was building my CPU. It is a simple program that goes into an EEPROM that allows binary input to be converted into decimal numbers, and those decimal numbers displayed on an LCD screen. Now, all of this is done via 16 byte information within the EEPROM, and it's pretty straightforward in C. There's a couple caveats which I'll show you when I show you the code that you need to keep in mind, but otherwise it's a pretty straightforward C program, and I wanted to see how the AI dealt with it and converted it into Rust. And I'll show you the Rust code later as well. But one of the first things I'm going to show you is the actual hardware and an operating EEPROM, which has the C code on it and shows you how it's meant to work. And then I think I've got a video somewhere. If I do, I'll put it up of how it's made. But basically, I'm just going to try and swap out the EEPROMs to, and in theory, the file generated and loaded on the EEPROM by the C program and the file generated and loaded on the EEPROM by the Rust program should be the same, and therefore they should work, but they don't. So let me show you what happens when I plug it in and try and get it to run. Right, so here you can see it running. The EEPROM with the red tape on it is to keep any UV light out and stop it from being erased by natural sunlight. I can change the inputs at the top, and it will generate the digital number. The flashing lights on the left are to show what input is going into the actual LCD. Not the numbers, but the input into the LCD, which will make it display the numbers. Now, here is the one with the Rust code on it, right? And so when I load this into the same place and turn it on, in theory, it should just work, but it doesn't. And in fact, you can see the lights flashing mostly because it's just getting zeros. It's not actually getting any input for the LCD. So something's wrong with the file that got blown onto this EEPROM. It's difficult to swap out EEPROMs for me because it takes me 5 hours to actually wipe the EEPROM. I don't have a proper UV light eraser. I just use a dental eraser which happens to have UV light, but it kills bacteria. But it works. It just takes a lot longer. So I've loaded onto both of these, and as you can see, it doesn't make any difference whatsoever. They just don't work. So shortly after this, I stick it back in the UV light and try and get it to erase so I can try it again. Now in normal operation, you get the 4 bytes, or you get 8 bytes and then the next 4, and they're connected to that 555 kind of timer in the switch. So it counts. And then the output comes from the EEPROM out into those yellow wires, and then that goes into the LCD, and it should display the numbers. And with this one, it does correctly display the numbers. However, with the Rust code, it does not. Now, this EEPROM does the conversion from the input into what is required to display it on the LCD. Those lights are showing what is the inputs to the LCD, which if you read the data sheet, it'll tell you what you need in order to display the cursor, etc. But that's all loaded into this based on those hexadecimal numbers, and I'll show you that in the code where I've got display on, clear display, etc., and it gets loaded into the EEPROM at certain memory positions based on what the counting is on the input side. So you get the standard input, which doesn't change for those 8 bytes, but then it basically goes up to count, and that tells the EEPROM what to output. So the C program that I started with, it's very simple. It has the size of the ROM, it has the units, the digits that are for the decimal conversion that the LCD screen uses, and it has a write to binary. Now the important part here is that on the F write in C, I'm using a size T of 2 because I wanted to output 16 bytes of data, right? And so all it does is it builds up the data and then it writes the binary file out of the correct size. Here it builds up the data based on the position in the file that's going to come in. So it starts at 0 and goes to FFFF. When it gets it in, it has defined display on, clear display, no op, etc. This is all for the LCD, and then it switches. Here it will return a digit. These are what it's going to display. So it's really straightforward. There's not a lot to it. So I asked Chat GPT to convert this to Rust, and this is more or less what it came up with. There was a couple versions, iterations that I had to do, and once I got it, I had to manually change some things in order to get it to compile, and I needed to add some things in order for it to correctly write out 16-byte files. Now, it still doesn't work, and it needs some more troubleshooting, but from a point of view of just a basic skeleton that it's converted for you to work with, this is quite good. It is very, very good, but it needs human help to actually get it working. Now, you might say this isn't an easy C program, but it really is actually fairly straightforward. And in theory, this Rust program should have been a lot easier. But it doesn't work. And it needs more work and some human interaction. But I think it will work eventually. But at the moment, it's broken.